And for section 2.3, some statistical graphs. So in this section, I'm going to go over several different types of graphs and basically just do one example for each. So the first one is a dot plot. And what you do is just draw a number line, and then you put a dot or a circle above each number that shows up. So for example, these are ages from one of my previous stat classes, the ages of the students, 18, 20, etc. And here's my dot plot. So I just drew a number line. The youngest was 17, and the oldest out of this small sample was 24. Hold on, that's not what I want to do. So then you start with the 18, and then you put this first dot right there. For the 20-year-old, you put a dot. For the 22-year-old, you put a dot. And then you'll see that somewhere over here, there shows up another 18-year-old. So you put another dot. So I can very easily look at this and say, well, in this sample, there was 3 19-year-olds and there was 3 20-year-olds. There was only one 24-year-old. And as you do this more and more, you can sort of see the distribution, how the dots are. And yet it's very easy to do. And you can just look at it and see, oh, this class had one 17-year-old. Without even looking up here, I can just see it real easily. So that's a dot plot. Pretty easy and fun. Stem and leaf plots. So when we had classes in person, I would always, the day after an exam, return the exams and even show them a stem and leaf plot of how the class did. So let's say these were the scores. So stem means take something like 99, and in the tens place it as a 9, and the ones place it as a 9. This 7 has a tens place it as a 7, and the ones place it as an 8. So you're basically just separating it as the tens and the ones, or the stem and the leaf. So this represents everybody that got in the 90s. Here's everybody that got in the 80s, the 70s, and the 60s. And then these are put in order, so from smallest. So the smallest 90 was this person right here, so they got a 9D. And then this person got a 93, so 93. And if there's repeats, if there was another person that got 93, then I would just have another 3 in right here saying somebody got 93 and somebody else got 93. So that's how you do it. And at the end it ends with 60, so that is this person. And then a 65, so that's this one. And a 68, so 68. So this is the stem, and these are the leaves. Again, pretty easy to do, and you can always read the numbers off of this little graph right here. Next is a Pareto chart. So these are bar graphs, and they're used when the categories are not numerical. What I mean by that is this person has $2,000 a month in bills. So a car is not numerical. Rent, the word utilities, those are not numerical. Yes, the amount of money that they spend on it is, but the word utility is not numerical, so it's just a category. And here's how you do it. So you usually put them in order from the biggest down to the smallest. That way you can see what's the most. Rent, they need to contribute $600. So you put the biggest one first. And then childcare, that is right here at $400. So it goes up to 400. And then food, 300. The car is 300. Utilities at 200, and clothes at 200. So that is a Pareto chart. Now, if this chart did not start at 0, then the proportion of these heights would be exaggerated. So on the homework, they're going to show you some examples where perhaps they would have one that's really big right next to one that's really small. It's because they're not drawn proportionally. So you got to watch out for that sometimes. Now what's called a circle graph, or more commonly a pie chart. So we're going to use the same information, but then make a circle graph. So when you draw these, it doesn't have to be perfect, but you could see that the rent is the biggest piece of the pie. The food is 300 and the car is 300. So this and this, they look to be about the same. And then utilities is 200 and clothes is 200, so these are smaller. And then the total is a grand total of $2,000 in bills per month. So that is a pie chart. Next, a scatter plot. So this is just like in algebra. When you have an x and a y, you draw the x-axis and the y-axis, and then you plot the points. So people were asked their age and how many speeding tickets they had in the last 3 years. They put the last 3 years because that's what affects your car insurance, how many tickets or how many points you have in the last 3 years. And then make a scatter plot. So here's the information. There was a 24-year-old person, they said they had 1 ticket. A 21-year-old person that had 3 tickets. They're paying a lot for insurance. An 18-year-old with just 1 ticket, a 26-year-old with 0 tickets, etc. So this goes first, so this is going to be the x-axis. Tickets goes second, so that's going to be the y-axis. So here on the x-axis, I have the ages ranging from 18 up until 29. And for the tickets, the choices are 0, 1, 2, 3. So 0, 1, 2, 3 on the y-axis. And then for this person, 18 and 1, so just go over to an 18-year-old that has 1 ticket. Here's a 21-year-old that has 3 tickets. 22-year-old that has 2 tickets, etc. So you just make the dots, and then you try to see, is there a pattern? Well, with this one, there's not much of a pattern other than these younger people seem to have more tickets than these older people. So these older people are wise. They know how to not get caught. Or perhaps they just don't speed. All right, so that's the scatter plot.